So for the first one, it asks, for which of the following does limit of f of x as x goes to 4 exist? I recommend whenever you try these multiple choice type of questions where they give you 3 options like this, you always want to answer the question first before looking at the choices. It's the best strategy for these. So to answer this, when does the limit exist? We have to compare the limit from the left and the right. So we would compare the limit from the left, which is the limit as x goes to 4 from the left of f of x, and see if this is equal to the limit as x goes to 4 from the right of f of x. So we have to verify when is this true, for which cases is this true. So if we look at the first case, the limit from the left, as we move closer to 4 from the left, it means we're going down like this. We're moving closer to 4, okay? And the limit from the right of f of x, as x goes to 4, you can see this is also going close to 4. Now you may ask, what is this thing here we're doing? Do we look at this? And here's the thing, they try and trick you by putting this dot up here, because although f of 4 exists, the limit of x, the limit of f of x as x goes to 4 is the y value of this and not this. So this y value, if we count this, looks like it's 3. So it means that for this one, the limit as x goes to 4 of f of x is 3. So the limit exists here because the limit from the left and right match. In this case, both of these say 3. So for case 1 is true. Now let's look at case 2. Same thing, limit from the left, we're going like this. Limit from the right, we're going like this. Both of them are approaching something here. And that something is this y value, which is 1, 2, 3, 4, it looks like. So the limit exists because the limit as x goes to 4 of f of x is 4. So the limit exists for this as well. But now let's look at the last case. And we're going to do the same thing. Compare the limit from the left to the limit from the right of 4. So from the left, we're going like this. So from the left, we're approaching whatever this y value is. And from the right, we're going like this. And we're approaching whatever this y value is. Now you can immediately see that these two y values are different. And you can compare the two. This is 1, 2, 3, 4. And this is 1, 2. So the limit from the left of 4 is approaching 4, and the limit to the right of 4 of f of x is approaching 2. So because we have 4, I'll just copy this. So we want them to be equal, right? But in this case, the limit from the left of 4 is 4, and the limit to the right of 4 is 2. And this is not true, so it means the limit does not exist. So you would just say DNE for limit does not exist. Does not exist. So it only exists for choices 1 and 2, which means it's D. Okay, moving on to the next one. So for this one, this is a trig limit. You have to make use of the identity. This is what you always should do when you see limit as x goes to 0 in sine. It's very handy to use this. So now let's see what we can do here. So immediately we see that limit, we can rewrite this as limit just to make this simpler to look at. Separate this into two things like this. So 3 over sine 3x times sine 4x. So I didn't change anything. I'm just rewriting it so it's easier to break down what's going on here. And now what we can do is we can also make use of the fact that limit as x goes to 0 of x over sine x is also 1, as I mentioned. And we can make use of this here. So we have to break this down into two things. We want to make it so that we see the same term here as we see here. Because right now this is 3 and this is 3x, you have to make them the same. So you just do that by multiplying this by x, and then you get what you want, and then just rewrite this as it is. But then because we multiplied this by x, we also have to multiply it by 1 over x as well. So when we see this sine of something over the same something as limit as x goes to 0, this whole term is just 1. So we keep our limit, but we know this is 1. We keep our limit because we're still solving the rest of this. So now we still have to solve what is sine 4x over x. Okay, this term got eliminated because this is 1. 1 times anything is this thing. So now what we do is we want to rewrite this into something of this form now. Okay, the key is we want to make sure that we see the same term here and here. So if we want to get the same term here and here, we can simply write what we want already. Okay, we just want it to look like this. And now that we know what we want it to look like, to make this equal to this, you would just multiply this by 4. And this works because you can check, right? You can cancel the 4 and 4 into the same thing. So now what we do is we see that we have the case here, same term, limit as x goes to 0. Whoa. Okay, limit as x goes to 0. So this whole term is just 1. This whole thing is just 1. So then we're just left with 1 times 4, right? Because limit as x goes to a constant of a constant is just a constant. So if I were to write that out, limit as x goes to 0, this term right here is 1, and then this right here is just 4. So the answer is 4. And you don't even have to write it out like this. You can go straight from here, say 1 times 4, and it's 4. Now the next one, let me box my answer. Okay, now the next one. So for this one, it might seem a little bit intimidating, but whenever you see this, just remember that factoring is your friend for these questions. So just see what you can do with factoring. So if we try factoring, and the reason we can use factoring is just we have a difference of squares. When you have a difference of squares like this, a squared minus b squared, this is just equal to a plus b times a minus b. So we just make use of that identity whenever we factor here. So here this would turn into x plus a times x minus a. And then this one is also a difference of squares. The only difference is that it's x squared squared minus a squared squared. So in this case, our a is x squared and our b is a squared. So it becomes x squared plus a squared times x squared minus a squared. And now we see we don't get to cancel out anything, so we should factor this again because we still have a difference of squares. The whole point of factoring is so that we can cancel out terms. And from here we can definitely see we can cancel out a lot of things. So we can cancel out the x plus a with the x plus a and the x minus a with the x minus a. So now we're just left with right? And now we can just plug in our value. And if we do that, plug in the value for x, we get 1 over a squared plus a squared, which is just 1 over 2a squared. And that's the answer. Okay. And then the last question. So for this one, whenever you see a radical, for this type of question, you always want to make sure you're dividing by the highest power. So the way this works is the way this works is we now just divide by x squared by everything. But the thing is that we want to make sure that we're dividing inside this radical. Now the way we do that is we use what we already know about radicals. So if you have square root of a over square root of b, this is the same as square root of a over b. So we have to use this somehow. And the way we use this is just by dividing by x squared by everything. And then we rewrite the x squared for the numerator. So if we were to rewrite x squared is basically the same thing as square root of x4. That's how we can get the radical, because we want the radical so we can divide by it. So now this is divide by square root x4. And now we're dividing this thing by the entire denominator is being divided by x squared. The point of writing out the square root x4 is so that this x4 can slide inside the square root and cancel out some terms. So now what this achieves is if we are to slide in the x4 into the radical, it would look like this. We're just using this property here in this step. And in the denominator, we can simply just divide everything by x squared, right? If you have, let's say, a plus b plus c divided by 5, it's the same as a over 5 plus b over 5 plus c over 5. So we can just use that concept here. And if we were to divide it, we'd get 1 minus 3 over x plus 5 over x squared. And then we can still simplify and cancel out some terms here. So let's do that first. So this would become square root of 9 plus 1 over x4, and then you have the rest. And now the step here is just, you can just plug in infinity basically for everything. So remember that if you take the limit as x goes to infinity of 1 over x, this is 0. And you can extend this. If you take limit of x goes to infinity as 1 over x squared, this is also 0. 1 over x cubed, it's also 0. So that's why we can, and the reason why is if you take a huge number for x, 1 divided by a really, really huge number, it's going to get smaller and smaller and smaller as your number gets bigger. So you're approaching 0. So because of that, this term goes to 0 as x goes to infinity. This term goes to 0 as x goes to infinity. And this term goes to 0 as x goes to infinity. And then all you're left with, once you know that this, and this are zeros, you're just left with square root 9 over 1, which is just 3. And then that's your answer. Alright, so those are the challenge questions. If you have any questions, then let me know. Thanks.